In this exercise, we will draw a parabola from scratch, and this is just again a reminder of all the theory you need to know to do that. And we're going to draw the graph of y equal to 2x squared plus 4x minus 6. That is what we're going to draw, G. First of all, we want the x-intercepts. Just as for straight lines and for any other graph, when we want the x-intercepts, we make y 0. So in this case, we will have 0 equal to 2. Just written the x-intercepts there, and this is my axis of symmetry. And you will notice that the green graph here is my mother graph, y equal to x squared. So what happens? We see that we have g of x is equal to 2 times x plus 1 squared minus 8. So that means g is f stretched vertically by a factor, then shifted 1 unit to the left and 8 units down. And just take care that when you draw the graph that you never make this a sharp edge. So there's our intercepts, B and C. This is our turning point. And we just have to do all the work. Remember that g of x, we could also write it as 2x minus 1, x plus 3, and this is where we got the intercepts from. This is my ax minus b squared plus q, and then we draw our graph. And it's good also to draw in the axis of symmetry. In the answer, the document with the answer, you will also find this completion of the square, the one method where we divide by a. There's also another method, x squared plus 4x minus 6. I can divide by 2 and then I get 0 equal to x squared plus 2x minus 3, which makes the factorization easier because I just have a coefficient here of 1. So it's xx, and I cannot have other factors than 3 times 1. And I have a minus here, so it means that one bracket has a minus and one has a plus, but the answer must be plus 2, so the plus will go with the 3. And we must always check the inner and outer terms. So here I will get minus x, and there I will get plus 3x. So that is together 2x, so I know my factors are correct. This is equal to 0, so therefore x minus 1 is equal to 0, or x plus 3 is equal to 0. So x is equal to 1, or x is equal to minus 3. So my x-intercept is x equal to 1 or x equal to minus 3. That is my two x-intercepts. My y-intercept, I make my x is 0, so I get y equal to 2 times 0 squared plus 4 times 0 minus 6. And you will notice this is just a c value. My y-intercept is y equal to minus 6. So here I have my x-intercepts, my y-intercepts. So now I want my axis of symmetry. That happens at minus b over 2a. Remember my standard form is y equal to ax squared plus bx plus c. So my b in this case is minus 4, and a is 2, so it's 2 times 2, so that gives me a value of minus 1. And this is a vertical line, x equal to minus 1. This is also my p-value, that's also minus 1. And if I substitute p equal to minus 1 into this equation here, I get y equal to 2 times minus 1 square plus 4 times minus 1 minus 6, and that will give me 2 minus 4 minus 6, and that will give me minus 8. So PQ is in this case minus 1 and minus 8. So that is my PQ value. I can also complete the square for this. I don't need it, but I just want to use it later to show the shifts. So if I do completion of the square here, first of all I've taken out the 2 in the first two terms here, and then inside I'm adding half of the middle term, the coefficient of the middle term, which is 1, square, and I subtract it again. So I'm just writing it there to remind us where it comes from, the square. It doesn't change the value though. So that will give me 2, and I'm going to combine those to get x plus 1 square, and then I'm going to multiply the 2 with this minus 1. So outside it will be minus 2 minus 6, so that gives me 2x plus 1 square minus 8, which also corresponds to the, written here, infinity, it's minus 8. So this is my Q value, and my P value is also in that equation there, because the x plus 1, it comes from 2x minus 1 square minus 8. So this is my P value, and this is my Q value.